Hi friends, today we are going to learn Apple laptops adapter in and battery charging sections. So in the screen you can see there are some components. I'll introduce you first the component. So this is my adapter input, this is my battery input, these two supplies are input and this section is the output. So in this within this section these are the controller. This entire is a controller who take the voltage in from either from adapter or from battery. And on the right hand side corner there is one chip. This is called the SMC chips, system management controller chips. The system management controller chips work is to manage the power, manage the temperatures, manage the fans, etc. Now when we connect the adapter, the power goes in two directions, from this direction and from this direction. There are two directions. Okay, so either if we can connect from the adapter, my power is go from here or and here. If I connect from battery, my power is go from here or from here. That means there are two direction of the power. So if I connect the adapter, my power goes to like this. You can see in this animation it goes to this diode's anode, from diode cathode, and then it goes to this pulse width modulator. This pulse width modulator receives the 16.5 volt from the adapter and convert this 16.5 to 3.42 volt. Okay, it received 16.5 volt from this side from the adapter and convert into 3.4 volt 42 volt DC. And this DC voltage 3.42 voltage DC volt goes to the SMC chips. So this SMC need a 3.4 voltage that goes to the SMC. Now SMC got the power on. The next is and the second thing here we are mentioned 1 2 3 4, like 1 2 3 then 4 5. These are the sequence, and that sequence the power goes. That is a rhythm of the power. Okay, so now the SMC got the power 3.42 volt. Next SMC need a reset signal. This small 6-pin chips generate a reset signal to the SMC. Now it is a 0 volt. Now it's become a 3 volt. It's become a 3 volt. So SMC got a reset signal, and now SMC ready to work. Okay, so the next is now we see how the power goes from this direction. In another way the power goes in here also, on both the side, here and here. Now the power goes in this direction. You can see in this animation power goes here, it stop at that MOSFET. This 8-leg MOSFET. These are the 5 MOSFET. This is controlled by this battery charging chips. The chips number is 6259, ISL 6259 chips. So now this ISL 6259 chips need a power to work. He get the power from this adapter. That pin name is DC in. DC in. That is step number 4. So now the battery charging get the power from this adapter. DC in 16.5. The next is AC in signal, adapter current in signal. This is a signal. It's supposed to come 3.4 volt at this pin. If 3.4 volt 42 volt come here, that means this chip will come to know that is getting the power from the adapter. So here are two resistor, R1 and R2, which is current dropping resistor. We reduce the voltage and 3.42 voltage generated and sent to the AC in pin of this chips. So now this ISL 6259 chips, battery charging chips, got the power, got the signal. That signal known as AC in SIP. AC in, that means adapter current in 3.42 volt. After receiving this signal, this chip omit one signal that is called AC OK. That means he received AC in, adapter current in is there, and he sent one signal out, that is AC OK, adapter current OK. and he sent to the SMC. Now the SMC come to know that he is getting the power from adapter. Here you can see everything is work on a logical basis. Okay, so SMC got the power from here, he's got the reset, then he's got the AC OK signal, that means adapter current OK signal. Now SMC will communicate with this battery charging chips with this SM bus. This bus is called system management bus. This is a two-wire communication protocol. SM data and SM bus is a two-wire communication. It's a bidirectional data bus. Like in the chips, they are communicate with each other. So at step number 7, here this ISL62599 chips communicate with the SMC, and they communicate, and now this SMC will tell this chips you trigger this 2 MOSFET because the power comes in. Now it's to take it in. So this chip trigger this 2 MOSFET, trigger this gate. First he communicate with this chips, and after that he trigger this 2 MOSFET. You can see in this animation. Okay, so at step number 8 he triggered 2 MOSFET. After triggering this 2 MOSFET, the voltage which is halt here, which is stop here, now pass to the MOSFET, both the MOSFET, and pass to the next section. So you can check the 16.5 volt at this current sensing resistor, the green color resistor, small resistor, which value is 0.02 ohm 1 watts. You can check this voltage at this resistor 16.5 volt, and if the voltage is not coming at this point, particular point, that means possible problem could be this 2 MOSFETs are not okay, or they may be open, or they are not getting trigger from this chips, or this chip is not getting AC in signal. Either any of this, you have to check previous sequence for that if the voltage is not coming here at this point. Okay, the next is the voltage goes to this MOSFET number 3. Here are 2 MOSFET number 3 and MOSFET number 4, and one coil is connected here, one capacitor is connected here, and this 2 MOSFET triggering by this chips, battery charging chips. Now my output sections require as 12.6 volt. Okay, my system need is 12.6 volt to work, but my adapter is giving a 16.5 volt. So here, and my battery is also 12.6 volt. So here I have to reduce the voltage to 12.6 volt. In this, with the circuit we are talking about Apple MacBook Pro models. Okay, so in Air this voltage could be the 8.6 volt. In Pro it is 12.6 volt. Okay, so in this we have to reduce the voltage, so that's why they use this circuitry is called the pulse width modulator. 2 MOSFET, upper MOSFET, lower MOSFET, coil, and capacitor. Now once he received the signal from the SMC, the ISL6259 chips started triggering this 2 MOSFET, upper gate and lower gate started triggering this 2 MOSFET. So here the plain DC voltage started chopping at this point, and pulsating AC voltage will be generated at across this coil. This coil will generate a back EMF past the DC voltage, which is gathered across this capacitor, filtered it is, and sent to the output section, sent to the fuse, and output will receive a 12.6 volt pure DC output. So in this way we can see how the output voltage is coming out. If it is voltage is 12.6 is not coming across this fuse, then you have to check the back section, which we explained just now. The next is, if now the battery need a charge, here is a battery, if this battery need a charge, so now SMC this communicate with this battery through the SM bus. Here also 2 SM bus is here. In this section we can find the 2 SM bus. One is here from SMC to this chip, and another is from SMC to this battery. So in next sections this battery communicate with this SMC chips, and he asks, I need a charge, you please send me a charge current. So after that SMC will give command to this battery charging chips, and battery charging chips will trigger this. He generate this signal charge B gate. He send one signal like this trigger at this step number 12. Once it trigger this MOSFET, this voltage which is 12.6 coming here, it will flow like this. You can see in this animation, it goes to this battery and battery started charging. So that is step number 13. So in this way, we just now see how this sections work in this Apple MacBook Pro laptop. Now we are going to see how the laptop work on battery. Now we have just seen how the laptop work on adapter. Now we are going to see how the laptop work on the battery in this next slides. In this slides, adapter is not connected, so the output voltage, the AC in is 0, DC in is 0, this is no power. So but the SMC need a power. So what SMC will do, he take the power from battery like this, and my 12.6 volt goes to this pulse width modulator, and this pulse width modulator will generate a 3.42 voltage, and this 3.42 voltage goes to SMC like this. Now the SMC got the power from the battery. Because of this voltage is absent, here the voltage is 0. So now this SMC will come to know that he is getting the power from the battery, and he started communicate with the battery like this through the SM bus. You can see this animation, how they are communicating, and once they started communicating, the battery is sending a charge like this to this MOSFET number 5. He crossed the MOSFET number 5 because the gate voltage is absent. He crossed this MOSFET, goes to this current sensing resistor, and cross to this section and goes to this fuse. And in this way we can saw how the Apple MacBook Pro adapter current and battery section work. So thank you very much.